Welcome to aminacademy.com. In astronomy, let us discuss about Earth's crust. Let's now examine our planet's outer layer in more detail. Earth's crust is a dynamic place. Volcanic eruptions, erosion, and large-scale movements of the continent network the surface of our planet constantly. Geologically, ours is the most active planet. Many of the geological processes described in the sections. Now, composition of the crust. The Earth's crust is largely made up of the oceanic basalt and continental granite. There are both igneous rocks, the term used in the for any rock that has cooled from the molten state. All volcanically produced rock is igneous rocks. Two other kinds of rocks are familiar to us Earth's, although it turns out that neither is common on another planet. Sedimentary rocks are made of fragments of igneous rocks or the shells of living organisms deposited by wind or water and cemented together without melting. On Earth, these rocks include the common sandstones, shales, and limestones. Metamorphic rocks are produced when high temperature or pressure alters igneous or sedimentary rock physically or chemically. The word metamorphic means changed in form. Metamorphic rocks are produced on Earth because geological activity carries surface rocks down to considerable depth and then brings them back up to the surface. Next one, the primitive rocks. The fourth one, which has largely escaped chemically modification by heating. Primitive rocks represent the original material out of which the planetary system was made. Next, about plate tectonics. What is plate tectonics? Is a theory that explains how slow motion within the mantle of Earth move large segments of the crust, resulting in a gradual drifting of the continents as well as the formation of mountain and other large-scale geological features. Plate tectonics is a concept as basic to geology as evolution of natural selection is to biology or gravity is to understand the orbits of planets. Earth's crust and upper mantle to a depth about 60 kilometers are divided into about a dozen tectonic plates that fit together like the pieces of jigsaw puzzle. Next we talk about rift and subduction zones. What are they? Plates pull apart each other along rift zones such as the mid-Atlantic ridge. Driven by upwelling currents in the mantle. A few rift zones are found on land. The best known is the Central African Rift, an area where the African continent is slowly breaking apart. Most of the rift zones, however, are in the oceans. Fault zones and mountain buildings, what are they? Along much of their length, the crustal plates slide parallel to each other. These plates' boundaries are marked by cracks or faults. Along active fault zones, the mountain of one plate with respect to the other is several centimeters per year, about the same as the spreading rates along rifts. One of the most famous faults in the San Andreas Fault in California, which lies at the boundary between the Pacific plates and North American plates. Now we'll discuss more detail about these things. Now, first, Earth's crust is the outermost solid layer of the Earth composed of rock and making up less than 1% of the plate's volume. Earth's crust is about 1% of the plate's volume. It's divided into two main types, the thicker continental crust and the thinner, the oceanic crust. The crust and the uppermost part of the mantle from the lithosphere, which is broken into tectonic plates. Continent crust. It's found under continent and continental shelves. It's thicker, about 30 to 80 kilometer, and mainly composed of less dense felsic rocks like granite. It is also older, containing rocks dating back billions of years. Oceanic crust, found under oceans. It's thinner, 5 to 10 kilometer, and made of denser mafic rocks like basalts. It's also younger, with none older than 170 million years. Lithosphere, a rigid outer shell of the earth made of the crust and the uppermost part of the mantle. It's broken into tectonic plates that move very slowly. Moho, the boundary between the crust and the mantle where seismic waves change speed, is called moho. Now, composition of the crust. The Earth's crust is primarily composed of a solid rock and many minerals, with the most abundant elements being oxygen, silicon, aluminum, iron, calcium, sodium, potassium, and magnesium. Specifically, about 46.6% of the crust by weight is oxygen, followed by 27.7% silicon, 8.1% aluminum, 5% iron, 3.6% calcium, 2.8% sodium, 2.6% potassium, and 2.1% magnesium. Plate tectonics. What are they? Plate tectonics is the scientific theory that Earth's lithosphere is divided into large, rigid plates that move and interact with each other. This movement causes the earthquakes, volcanoes, and mountain ranges. The theory explains how the continents have moved over millions of years and how Earth's surface is constantly changing. Rift and subduction zones. Rift zones and subduction zones are distinct features related to plate tectonics, where the crust is either created or destroyed, respectively. Rift zones are divergent boundaries where plates move apart, leading to the formation of the new crust, like mid-ocean ridges, and the potential for volcanism. Subduction zones, on the other hand, are convergent boundaries where one plate slides beneath other, destroying crust, and often associated with volcanism and earthquakes. Fault zone, mountain building, how the mountains created here. Fault zone and mountain building are closely related processes. Fault, which are fractures in the Earth's crust, can be a significant factor in the formation of mountain, particularly fault block mountains. Large scale faulting, especially along divergent plates boundaries, can lead to the uplift and tilting of land blocks, creating mountains. So far we discussed about Earth crust. We have done. Please subscribe our YouTube channel.